Hello everyone, this is Orhan. Welcome to the K-NearestNeighbors with Python lecture. In this lecture, I will show you how to use Python and scikit-learn to implement K-NearestNeighbors algorithm. Let's start with importing the libraries. Okay, these are going to be the libraries that I will be using, and the data is from Kaggle. So this is the web page that I will be using to import the data. I already imported it. It is below the video. The data is called credit. So let's start by importing the data. And then drop the columns with categorical variables. So loan ID and customer ID are the data that I'm not going to use. And then I will fill the variables with missing data. So income column has a lot of missing data, and I will be filling them with the median income of the whole data set. It seems that I made a couple of errors. Let me correct this Excel word here and the median word here and rerun. Okay, every line of this data set represents a customer. The first column shows whether they paid the loan or they did not, and the other columns represent several characteristics of that same customer. For example, this column shows the income of the customer. This is whether they have monthly debt or how many years of credit history they have, etc. The whole purpose of this research is to predict the loan status of a new customer. When a new customer comes, we are going to use KNN algorithm to predict the loan status of that customer. Is he going to fully repay the loan or is he going to be charged off? That's the whole idea. Now let's take a look at the descriptive statistics of the data. As you can see, some columns have 1000 rows, some columns have less. So that's why I am going to drop the data with missing values. My new dataset now has 768 rows. What I'm going to do right now is to create dummy variables for my output variable, which is loan status data. And there is another dataset here, which is called term. I'm going to create a dummy variable for term 2. A dummy variable is a binary variable that indicates the presence or absence of a certain category. Right now, loan status is a categorical variable that represents whether the loan is paid in full or not. When dealing with categorical data like loan status, we use dummy variables to convert these categories into numerical format suitable for statistical and machine learning models. In this context, fully paid will be represented as 1 and charged off as 0. In the first line, I created dummy for the loan status data. In the second line, I created dummy for the term data, which shows whether the loan is short-term or long-term. The third line, I dropped those variables plus home ownership and then purpose columns, which I'm not going to use. And then I'm seeing the first 5 lines of my data set. As you can see, loan dummy and then term dummy are here. Some of the data are in millions, for example, income. Some of the data are in tens, for example, years in job. Some of the variables are in 10,000. So the scale of the data is different across different values. I am going to normalize this. As you might remember, the code will be calculating the Euclidean distance between 2 points, and those 2 points would be in millions for income, tens for years in job, and 10,000s in monthly debt. So that's why some of the variables might seem more relevant than the other variables just because of the scale. So that's why I'm going to normalize this data using a code called standard scaler as follows. Okay, basically in this code, we are scaling data, we are normalizing the data except the loan dummy data because it should be between 0 and 1. So I'm going to predict whether a new customer is going to be 0 or 1. So that's why I'm not going to rescale it. It's going to be a binary variable. Now I am going to start the train test split. This code is basically taking 70% of the data as training data, and then using those 70% of the data, I'm going to use 30% of the data to test my predictions. Right now, I am taking k as 1. So in the coming lines of the code, I will change this to different variables. Right now, it is 1. This last line is making predictions in the test data set. Now let's take a look at the evaluation of my predictions. Okay, so this shows us our confusion matrix. If you don't remember what is what in this matrix, it might be better to take a look at the classification report, which is more explicitly summarizing the results as follows. Okay, so this output shows us the precision and recall for each category. For category when loan dummy is 0 and when loan dummy is 1, and then their average precision and recall numbers. So as you might remember, precision is the positive predictive value and recall is true positive rate. So basically this chart is showing us the performance of our model with k is equal to 1. Now I will write a code in which I am going to change k successively from 1 to 40 and see their error rates, and then depending on their error rate, I'm going to change k. So basically this chart shows us the error rate with respect to k value. For every single k, there's a corresponding error value here. As you can see, when you increase the k, the error value decreases up to some point and then it stabilizes. So we can take a look at different k's here. For example, it seems that when k is 16, we reach the lowest error. I'm going to copy and paste the above code here and change k to 16 and see the precision and recall values of this new model. Okay, as you can see, when I increase the k from 1 to 16, the precision increased to 91% from 49%, and recall value increased to 52% from 49%. So this shows that when you change the k, the precision and recall values of your model will change. So in this video, I showed you how to use the K-NN algorithm in Python. And hopefully you enjoyed the video, and then this helped you to understand the K-NN algorithm. Hope to see you in the next videos. Bye.